Okay, now one calculation which a lot of people do struggle with, but it's actually very simple, is percentage composition. Percentage composition, there we go. Now percentage composition, that is required for both foundation and the higher tier papers. But we're also going to look later on in the video at how we calculate the empirical formula of a compound, which I'll come on to. That is only required for the higher tier. So once I get onto that, obviously if you're taking the foundation tier paper, then you do not need to worry yourself with that. Okay, so what do we mean by percentage composition? Well, percentage composition just tells us the percentage of an element in a compound by mass. This is the important word here, by mass. Because, for example, I could have, now this compound completely doesn't exist, but it's going to prove a point. If I had the compound H2O, okay, that doesn't exist because we know that H2O is how we normally find hydrogen bound to oxygen. But let's pretend, for example, that we had H16O. Now, hydrogen has an atomic mass of 1. Oxygen has an atomic mass of 16. So what we'd do is we'd add up all the atomic masses to find the formula mass. If these terms aren't familiar to you, then please look at my previous videos on formula mass and relative atomic mass. But the relative formula mass is going to be 16 lots of 1, which is 16. So 16 times 1. And then we're adding our oxygen, which weighs 16. And so that will give us a total mass of 32. Now, if I want to work out the percentage composition of hydrogen in this substance, I do not think about how many atoms of hydrogen there are. There are 16 atoms of hydrogen for every 1 oxygen. And so you could say, well, 16 out of every 17 is hydrogen, so the percentage is going to be 16 over 17 times by 100. This would be absolutely incorrect, because the definition is percentage by mass. This is not taking mass into account, this is taking numbers into account. And so this is incorrect. What we do is we say, well, what is the total mass of hydrogen in this formula? The total mass of hydrogen is 16 times 1, which is 16. I'll do that in a different colour. The total mass of hydrogen is here, 16 times 1, which is 16. And we divide that by the total mass of the compound. And that in this case is 32. That is going to give us 0.5. As a percentage, we then multiply by 100 and we get 50%. So in this completely imaginary compound, which certainly doesn't exist, we have 50% composition by mass hydrogen. If we had did it the other way, we would have had 16 over 17. And that would have given us around about 94%, which is very different to 50%. So you've got to be very careful here. And so how about we have a look at a real compound which does exist. H2O is how we normally find hydrogen bound to water. Now H2O, let's work out the formula mass from the atomic masses. So the atomic mass of hydrogen is 1, so hydrogen is 1, and of oxygen is 16. And we only have 2 hydrogens, and so that means that our formula mass, so Mr, is equal to 2 lots of your hydrogen, which weighs 1, plus we only have 1 oxygen, which is 16. And that will give us a total formula mass of 18. So, if we want to work out our percentage composition of hydrogen in water, we need to use this here. So, what we have is 2 times 1 is 2, and we divide that by our total formula mass, which we worked out to be 18. That will give us an answer of around about exactly 0.111 recurring, which is the same as 1/9. We then times that by 100 to get our percentage composition, and so we get 11.1, I'm not going to write the recurring, I'm just going to leave it as 11.1 to 3 decimal places, because chemistry is very different to maths in that it is not a absolutely exact science. Okay, so we get 11.1%. So 11.1% of our water is hydrogen, and that is because hydrogen doesn't weigh anywhere near as much as the oxygen does. And so if we did exactly the same calculation and we worked out the percentage oxygen by mass, then we are going to get 88.9, because it's the difference between 100 and 11.1. And I could prove that by saying oxygen is equal to, well, how much does oxygen weigh? 16 divided by our total, which is 18, which will give us 0.888 and so on 9, which we will times by 100, and to 3 decimal places, that is 88.9%. And so that is another way to check really whether you've done the right thing. If these percentage compositions add up to give 100%, then you have probably done it right. Okay, so one more example. We're going to do something slightly more complicated. We're going to have a look at a hydrocarbon. So something you would have seen in the previous course. So if we have C2H5OH, hopefully you can remember that this is ethanol. Ethanol. So our friend alcohol. And we have 2 carbons, 1, 2, 3, 4, 5, 6 hydrogens and an oxygen. So I'm going to write the atomic masses now. Hydrogen is of course 1, carbon 12, oxygen 16. Now our MR, I'm going to write that down here so we've got space. Our formula mass is going to be 2 lots of carbon, because we've got 2 carbons, plus 6 lots of hydrogen, which weighs 1, plus 1 lot of oxygen. And if you do that sum, you're going to get a grand total of 46. So our formula mass of ethanol is 46. And if I asked, what is the percentage composition, so the percentage composition of carbon in ethanol, what we're going to do is we're going to take the total mass of carbon in ethanol. And that is not 12, because we have 2 carbons. So it's going to be this here. I'll do it in a different colour. It's going to be this here, which is 2 lots of 12, which is 24. We're going to divide 24 by our total formula mass, which is 46. And that is going to give us an answer of 0.522 to 3 decimal places. It's actually 0.52173 and so on, but I've rounded it to 3 decimal places. Now, if I times this by 100 to get a percentage, that is going to give me 52.2%. And this is our answer for the percentage composition of carbon in ethanol. Okay? So now, remember I said if you are taking the foundation tier, you don't need to worry about empirical formula. And so if you are taking the foundation tier, feel free to rewatch this video as many times as you need in order to understand the concept fully, but you don't need to watch from now on. And so now we're going to take a look at what is known as the empirical formula. Let's spell empirical formula. Now, all the empirical formula means is it is the simplest ratio of atoms within a molecule or a substance. So, for example, if we had the substance C12H24O12, okay, we can write that more simply in the empirical formula as saying that the simplest ratio between them, well, we have 12 to 24 to 12. Now 12 goes into all 3 of these numbers. So we just divide by 12. 12 divided by 12 is 1. 24 divided by 12 is 2. And 12 divided by 12 is 1. So for every 1 carbon, we have 1 oxygen and 2 hydrogens. And so we can write that like this. C, H2, and O. Because we have 1 carbon 2 hydrogens, 1 oxygen. That is the simplest ratio. It doesn't tell us which substance we have, but it does tell us the simplest ratio of carbon, hydrogen and oxygen. In this case anyway. This can be used on any compound that you may come across. Now you're probably asking yourself, well, what has that got to do with percentage composition? Now the point is, sometimes it's very difficult to actually calculate the molecular formula or the formula mass of a compound. That's because it takes a lot of sensitive equipment and different experimental techniques in order to get that information. But we can quite easily work out the percentage of different elements in a compound. That is way easier. And so if we can calculate percentages of the elements, there we go, the elements, from that we can calculate the ratio of those elements. We can calculate the ratios. Now the ratios are going to give us the empirical formula. They're not going to give us the molecular formula, but they will give us the empirical formula. And sometimes that is very helpful. Even though we can't work out directly the molecular formula, the empirical formula will give us all different kinds of information. Now a good example of this is we are told that we have a hydrocarbon which contains 75% carbon and 25% hydrogen. So that is by mass. Obviously percentage composition is by mass, not by numbers. From this we can work out the empirical formula of this compound. And the way we do it is we play a little trick. We pretend that we have 100 grams of the hydrocarbon. The reason we do that is because if we have 100 grams, 75% of 100 grams by mass is 75 grams. So that means we have 75 grams of carbon and we have 25 grams of hydrogen. Now the reason this is useful is because we are going to work out the amount of moles of each one that we have. Remember that moles will tell us what proportion of hydrogen and carbon we have in comparison to each other, because 1 mole of one substance, 1 mole of carbon atoms, will have the same amount of atoms as 1 mole of hydrogen atoms. And so that means that we can disregard their mass. At the moment we've only got 75 grams and 25 grams, and that doesn't really tell us too much. So 1 mole of carbon weighs 12 grams. And so if we had 12 grams here, we would divide it by 12, and that would give us our 1 mole. So the way we calculate the number of moles is we divide it by the mass of 1 mole. So 1 mole of carbon is 12 grams. And so 75 divided by 12 is going to give us how many moles we have. And that is actually 6.25 moles. You do that in your calculator, you don't have to work that out in your head. Now, hydrogen has a molar mass, or an atomic mass, sorry, of 1 gram. So 1 mole of hydrogen weighs 1 gram. So here, if we had 1 gram, we would divide that by 1 and we would get our answer of 1 mole. However, we have 25 grams, so you should probably realise already that's going to give us 25 moles. Because all we do is we divide it by our mass of 1 gram for every mole. And that will give us 25 moles. So, for every 6.25 moles of carbon, we have 25 moles of hydrogen. The way that we work out the simplest ratio is we divide by the smallest number. Because if it was, for example, 2 to 4, if you divide both sides by 2, you would get 1 to 2. Okay, because you've divided by 2 there. We do no different here, except you're probably going to use a calculator. We divide by 6.25. Something really important I'd like to say quickly is sometimes in questions, the numbers won't give you perfect whole numbers at the end. But if they are very close, you can take that as being the ratio. In this case, we are going to get whole numbers because 6.25 divided by 6.25 obviously gives us an answer of 1. 25 divided by 6.25 gives us an answer of 4. So that means that we have 1 carbon for every 4 hydrogens. Okay? So our empirical formula is going to be C, only one of them, H, 4. CH4. Now, you don't need to know this, but there is only one hydrocarbon with that empirical formula, and that is methane. And so that means if we'd done this experiment, even though we haven't used expensive equipment to see exactly what the molecules are made of, we have found out by percentage composition the empirical formula, which has then told us exactly what hydrocarbon we're dealing with. So we have methane there, CH4. Okay, so I hope that's given you an idea of how we work out the empirical formula from our percentage composition. Now, I know that this topic does confuse some people, so I will be going through past paper questions on this as well, so please do check those out. But if you do have any questions, feel free to email me or leave a comment in the box below and I'll be happy to answer. So thanks for watching and I'll see you in the next video.